So just a few implementation scenarios just to show you. We've used a generic router over here. This is our Heli-22, which we will get to the overview later of the antennas, but just to show you how circular polarized antennas work, at least how to configure them. So on the specific Heli-22, it's quite a unique antenna. I haven't seen anything else in the market like this. We do have some competitors on some of our other ranges, but we haven't seen something that is dual band firstly per antenna or multi-band. So as I said, we have an antenna that, or actually Ernst mentioned that we have an antenna that goes from 1.7 gigs all the way to 7.2 gigs for Wi-Fi 6, that is 802.11 what's it, AX. And also for 5G, LTE and 5G. But this specific antenna that we're showing over here, Heli-22, is based on the ISM frequency bands, which is used in Wi-Fi, that is 2.4 and 5 gigahertz. And so when I say 5 gigahertz, I actually mean that it goes all the way from 5 to 6 gigahertz. That's just the band. And just to show here, because a lot of our customers are not sure how to connect them and how they are configured. But just to show that the one antenna is set up to be left-hand circular polarized. And if you remember the previous slides, I've shown left and right-hand circular polarization. But we'll also give a little bit more information on that soon. But the first antenna, so this is actually an antenna assembly that we sell as the Heli-22, which is physically got two bidirectional antennas. Each antenna radiates in both directions. So you don't need to connect two routers or two access points or nodes or radios to this unit. It already splits the signal in both directions. So you would have transmission in one direction and the other direction, perfectly suited for tunnels. So if you install this in a normal automotive or mining tunnel, you would actually propagate both ways down the tunnel, which makes it a little bit more effective. The one antenna, as you can see over here, is left-hand polarized, and the other one is right-hand polarized. So I'll just give a little bit more information on that as well. The bracketry and all the accessories that we have outside of the antenna radar, it's all stainless steel 316. Just for information, we use marine grade stainless steel for underground environments because we do know that there's a lot of chemical and salts and let's say water and so on that could corrode the metal. So we use the highest grade for this type of application. Just indicating over here is a generic router. I know that there's some routers that are connected differently, for example 2.4 here and 2.4 over there, but just for this example, just to show you that how one connects these antennas is each antenna on this assembly has two ports. The one is a 2.4 gig port, as you can see over there, and the other port is a 5 gigahertz port. So by using this, the 2.4 and 5 on the one antenna, left-hand circular polarized, and 2.4 and 5 on the other antenna, right-hand circular polarized, provides MIMO and diversity across the two antennas. So whereas I know some customers do use, let's say, an antenna in, so splitting their MIMO in both directions, which is perfectly fine, but just to indicate that this antenna offers actually MIMO in both directions, which is quite nice. Good. The same, not to go through this one too much, but the same with our Heli-21 antenna, which is a directional antenna, and this is typically mounted on the, let's say, the beginning of the tunnel or the end of the tunnel, or where you have a T-junction. Also connected in the same way. Both antennas have both 2.4 and 5, and then you have the left and right hand polarized. Just to mention quickly, this bracket that we have over here is, this is just one of our brackets. It is a roof mount bracket, and we also have one that is roof bolt for mining, where they have these roof or ceiling bolts that mounts directly to that. It's got a small platform over here for generic routers, so quite a lot of routers, IPs, radios, nodes can actually connect directly to this, and it just makes installation easier. All that this needs is, if this is a mesh node, it just needs power, or if it is let's say being sourced by an Ethernet connector, then it's just a power over Ethernet. So that's all you have to take to this antenna, and you don't need all the other power supplies and also have the routers and IPs mounted in a different place with long feeder cables. The shorter feeder cables also help quite a lot to reduce the attenuation, improves the throughput and signal quality. Good. Next slide over here. Peter, you are just going to go over this one.
Yes. So this is a case in point where we've seen deployment of access points underground. Now, with access points, as you can see there, these are vertically polarized antennas. But what we did find was that these needed to be in excuse me, in distance of about 100 meters apart. Just to get the signal propagation properly along the tunnel. So if you can go to the next slide, Stephen.
Yeah, so now it's just the, yes, the, let's say the case study or the business case.
Yeah, so assuming that we are going to deploy these routers over 5 kilometers, you can see the calculations there, the router or radio, the antenna and the installation, and that gets you roughly to around $230,000. I must say those are generic numbers, so you can plug in your own numbers to give you an indication of what this cost will be. Okay, next slide, Stephen.
Yes, just to mention something quickly on this also is that we've also seen, okay, so it can be 150 meters. We've also seen, 100 meters, 150 meters apart. But it seems like the deployments with these linear antennas are very limited. And it just means so many more access points. So I'll just quickly go to the next slide.
Yep. So this will be the deployment that we would suggest to the client. You can see there that we quite comfortably do 400 meters, which we were spanning in the previous slide. So your cost will come down to the next one, Stephen. So there you can see that to cover 5 kilometers, we will need 13 of these access points, these stations, so to speak, with the antenna costs. So we're looking there at around $67,600 thereabouts dollars. So if we compare that to the previous slide, you'll see that that is more than 3 times more to cover the same distance. So obviously with circular, you're getting better bang for your buck.
Yes, and just to mention over here that the 400 meters that is used over here is a specific case that we've had. We've had much farther distances that we have achieved in the coverage. So, but this is just a case study, and but we have achieved distances of 500, 600, and beyond. And just to mention that these distances quoted, they're very specific to the tunnel. You could have wider tunnels, thinner tunnels, rougher, smoother surfaces, depending on what frequency band you are using. So because customers always ask us, what is that distance that we should mount these antennas apart? My first comment to them is that it's good that the integrator actually does some system tests, put up some test antennas with the radios that you plan to deploy, and check how it performs, because every mine tunnel is different. But the values that we have used in both examples, I would say, is a little bit on the conservative side. But indicative of some kind of an average that we have experienced. Good.
Just something to add to what Stephen is saying, we have found that even along dog legs, you would find that the signal propagates pretty well. But as he quite rightly said, it depends also, of course, very much on the type of tunnel, the type of surfaces, and the dimensions, ceiling versus width of the tunnel.
Yes, but in our case studies, you'll get some examples of what our customers have done, and it's quite interesting to just see what the performance is actually.